This is pre-algebra lesson 8-4, writing rules for linear functions. Function notation is writing a function in what we call f of x form instead of y equals form. It looks like this. Instead of having y equals 3x plus 2, they just replace the y with an f of x, and it looks like this. F of x equals 3x plus 2. It means the same thing, it's just called function notation. Don't let it mess you up, it's basically the same thing. A function rule is an equation that describes a function. So the equation of f of x equals 3x plus 2 is an equation that defines a function. So if I needed to find whatever number I needed, like maybe the 18th term, I could just put in 18 for x and solve for that function. When dealing with functions, think of the value for x as the input and the value for y as the output. Right? So we have the input and we have the output. The y becomes your output. The x is your input. And the entire thing is your function rule. And it doesn't matter if it is written in f of x form or y equals form. If it's written in f of x form, the f of x becomes your input. Excuse me, your output, not your input. Okay, the f of x becomes your output. The x is still your input. And the entire thing is still your function rule. Let's look at something. It says, a long-distance company charges its customers a monthly fee of $4.95 plus 9 cents each minute of a long-distance call. We're going to write a function rule that relates the total monthly bill to the number of minutes a customer spent on long-distance calls. Okay. So the first thing we have to do is we have to make sure we understand what the question is saying. Okay. Our question says that we are going to pay a monthly fee. Our total bill is going to be $4.95 plus however many minutes of long distance we have to pay. Okay, so our total bill equals $4.95 plus our long distance charge. Okay. So let's let m equal my number of long distance minutes. So if m equals my number of long distance minutes, I know that my total bill is going to become T of m. T of m, because my total bill is going to be based off on the number of long distance minutes I call. The more minutes, the higher my bill. Less minutes, the lower my bill. So my total bill is a function of my number of minutes. Okay, so T of m equals my total bill as a function of minutes. So T of m then, my total bill, is going to equal my $4.95 a month I have to pay, plus 9 cents for each minute of long distance calling. So it should look like this. T of m equals $4.95 plus 0.09 m. Okay. Now, if we want to put it in slope-intercept form, because slope-intercept form is the form we're used to writing things in, okay, so slope-intercept form for the same equation would be T of m equals 0.09 m plus 495. Is one equation more correct than the other? No. It's just probably a good idea to get into the habit of writing things in slope-intercept form, because it's a really handy way of being able to graph things quickly and be able to look at things quickly. All right, now we're going to find the total monthly bill if the customer made 90 minutes of long-distance calls. So simply put it, 90 minutes of long-distance calls means substitute in 90 for m. M suddenly becomes 90. So in the equation, T of m equals 0.09 m plus 495. Okay, T of 90 means for 90 minutes is going to be 0.09 times 90 plus 4.95. If we multiply 0.09 times 90, we get $8.10. So this becomes $8.10 plus the $4.95 we already had to pay, which means total monthly bill for 90 minutes of calling is $13.05. Okay, so total monthly bill is $13.05. Not too hard, something similar to what you've been doing, except for now instead of putting it in y equals form, you put it in T of M or F of X or P of Q. Don't get so wound up in not understanding how to put it in T of M form or M of T form or something of that nature. It'll come, okay? Because I just know my total bills is a function of my minutes. Some people might have put B of M, bills, as a function of minutes. It doesn't matter. As long as you understand what you're doing, you're fine. You can write rules from functions tables as well as from sentences like we just did. Just remember that you find your slope as your difference in your f of x values, otherwise known as y, over your distance in your x values, and b is the value of f of x when x equals 0. Okay? So don't let this confuse you. F of x, remember, is another way of saying y. Okay? So the table may be written in f of x form, or it may be written in xy form. Same thing, basically. It means the same thing. First thing you're going to do is try to figure out your slope. Okay, so the first thing I'm going to do is I'm going to see what the difference of my f of x values are. Okay? I go from 3 to -5, -5 to -13, -13 to -21. Okay? From 3 to -5 is going down by 8. From -5 to -13 is going down by 8. From -13 to -21 is also going down by 8. So then I look at my f of x values. Okay, from 2 to 0, 0 to -2, -2 to -4. From 2 to 0 goes down by 2, 0 to -2 goes down by 2, and -2 to -4 goes down by 2. So my slope then, okay, my slope, M is going to equal the change in my y, which is -8, over the change in my x, which is -2, or the change of my f of x over my change of my x, which becomes 4 over 1, doesn't it? Or just 4. I don't care how you want to write that, 4 over 1 or just 4. Now remember, the next thing we need to do is we need to find out what is our y-intercept. Our y-intercept is when x equals 0. So if we look at my table, I look and find where x equals 0. X equals 0 right there. When x equals 0, f of x equals -5, which means that's the y-intercept. Okay? So when x equals 0, I'm going to move this down a little bit so you can see it. When x equals 0, f of x equals -5, so b is -5. So we put it in y equals mx plus b form. Okay, y equals mx plus b form, where we would have y equals 4x minus 5. Since this was written in x and f of x form, we'll replace the y with an f of x. So f of x equals 4x minus 5. If it's written in x and f of x form, that's the form you need to write it in. If it's written in x, y form, that's the form you need to write it in. So our function rule for this table is f of x equals 4x minus 5. Okay? Do the same thing with every other table. You look at the change of the y, okay, or the f of x, and then the change in the x. So here I'm going down 6, down 6, down 6. Here I'm going up 3, up 3, up 3. So my change is -6 over 3, which happens to be -2 over 1. My y-intercept is when x equals 0. So if I look at my table, x equals 0, f of x equals 0. So my b is also 0. So my formula would be f of x equals -2x plus 0, or just f of x equals -2x. And we can check and see if these are working by checking this out. If I put in 6 for x, -2 times 6 is -12. I could get a -12 out, so that seems like it's the appropriate formula. Okay, seems like it's the appropriate formula here. Let's look at the last one. The last one's written in xy form, so we can write it in xy form. So from a negative 11 to negative 7 is up by 4. From negative 7 to negative 3 is up by 4. From negative 3 to positive 1 is up by 4. From negative 6 to negative 4 is up by 2. Negative 4 to negative 2 is up by 2. Negative 2 to 0 is up by 2. So my slope is 4 over 2, which is just 2. When x equals 0, y is 1. So that means my y-intercept is 1. So I have y equals 2x plus 1. And I can check that. If I plug in negative 6 for x, I would have negative 12 plus 1, which is negative 11, which is exactly what my table says. So you can write function rules from tables. You can write function rules from word problems. You can also write function rules from graphs. Okay? You can write a slope-intercept form, f of x equals mx plus b, or y equals mx plus b. To write a rule, not a fool, that would be a rule, are, love my typos, for linear functions. Okay? Let's take a look at these. The thing we need to find, slope and y-intercept. You need to find your y, your b, and your m. First thing I always find is I always find my slope. I'm looking for my slope and my y-intercept. Okay? So first thing I'm going to do is, if I read from left to right, I'm going to start here, at this point right here, at 0, 3. I'm going to go down and to the right. So I'm going down 3 units and to the right 2 units. So my slope is negative 3 over 2. My y-intercept, if you notice, is at 0, 3, so my y-intercept is at 3. So my equation here, since it's written in xy form, not x, and how do we know that? Because it's labeled as x and y and not x and f of x. So y equals negative 3 halves x plus 3. There's my equation for something written in slope-intercept form, given those particular graphs. And let's look at letter B. Again, I need to find my slope and my y-intercept. Again, if I read from left to right, I start here at point A. To get to point B, I'm going to go up 2 units and over 4 units. So it's up 2 over 4. So my slope is 2 over 4, which is 1 over 2. And I can check that. Go up 1 over 2. Yep. Up 1 over 2. Yep. Still works. Crosses my y-intercept right here at 0. So my equation would be y equals 1/2 x plus 0, or just simply y equals 1/2 x. Either one is acceptable. I do not have a preference as to which form you write it in, whichever form you're more comfortable with. The last one over here, if I read from left to right, I start at B. Okay, I'm going to start at letter B, and I'm going to go up to letter A. So I'm going to go up 1, 2, 3 units, and I'm going to go over 1, 2, 3, 4, 5, 6 units. So up 3 over 6. So my slope is 3 over 6, which reduces to 1 over 2. Always reduce slope to lowest terms, never change it to a mixed number. And my y-intercept crosses my y-intercept again at 0. So my equation here is y equals 1/2 x. Exactly the same as the last graph, just a continuation of the graph a little bit further down the graph. So y equals 1/2 x. So if you can find the slope and find the y-intercept, you can clearly write your equation using slope-intercept. That's all there is to writing rules for linear functions.